And now, a word from our sponsor.
That's the infinite knowledge that I can access, but I've kind of capped my well. So I really love it. So seeing it presented now has opened up my well a bit more. I really appreciate it.
Abit's secret.
What was the target audience primarily? This book is for everybody. If it's early years, you read the story to them and you show them the pictures. And you might think some of these pictures are advanced, but for your early years, everything is advanced, everything is detailed. You're seeing detail in everything. So it's good for them to see those things at the early age, hear it in a natural story, and later on, as they get older, you unpack it. So it's from early years, even I'm a great fan of the pre-birth reason. So if you could have a one that is pre-birth, you read the story. Because it's about space, they're coming into a greater awareness of their space. So it's every age, every age. For a parent, it's a great insight for a natural, nature-centered way of learning. For a teacher, it's a great resource.
Abit's secret. Out now.
You need to be fully nourished. This book is one of the things we need to consume.
What I've seen in this book is that this book is revelatory also. So it's not just revolutionary, it's revelatory in terms of each piece of understanding builds a deeper understanding that actually comes from within.
Get your copy at abitsecret.co.uk.
And so it really provides a very deep and very clear step-by-step way for one to learn how to resurrect community.
Yeah, resurrect is it's a bold statement, but it's a true one. It's the resurrection.
It will be beneficial to the children, depending whether they're small, teenager or elder. Even us adults can learn from this book as well. So,
for more info or orders by phone, call 020-8144-1720.
The book was just amazing. It was a great read through. I just think it's a fantastic book. Bought 2 copies, one for me, one for my grandson. So I just know that it's going to be great. There's a wonderful website as well, and then there will be more books in the series, which I can't wait for.
ABITS secret.co.uk. abitsecret.co.uk. For more info or orders by phone, 020-8144-1720. Abit's secret. Out now.
Let's get it on.
Dr. Oyibo,
yes.
I just want to interject one thing. Later on, when people are looking at this, they will better understand exactly what unified theory is. So if you could explain that in terms of what it is we're really looking at.
Yes. Well, the unified field theory is a theory embedded in the human spirituality, in reality, that was supposed to show the connection, the unified position of all the forces, that says the forces if they're called forces, just like the human family, you should have the same origin. Okay, if you're a human being, you must have some kind of origin, common origin. Africans have the same great-grandparents, and and so on and so forth. So forces are therefore thought to have a common origin, except that the sciences, as they have it, have not been able to show that common origin. They will study those forces separately. They will see the effects. A few cases they have commonalities, other times they're separate. So the principle then of the unified field theory is to unite all the forces.
What are those forces?
Well, in reality, humanity doesn't know all the forces, but they claim to have identified 4, which are the gravitational force, which holds the planets and the universe together. Then you have the electromagnetic field, force, which holds, you have the electric fields and magnetic fields. They're responsible for energy production and so on and so forth. It's a very unique kind of field that moves electrons and all kinds of subatomic particles, and any object that has elements of electric or magnetic field or components in them. Then the third category, or which are actually 2, are the so-called strong forces and the weak forces. The strong force binds together the repelling components of the the universe system. For example, if you have 2 magnets, you have, the like poles would repel, okay, and unlike would attract. And so what happens is when you have those together, they will be bouncing away. That's a very, very strong kind of situation where they're trying to push one another away. So if you can imagine a force that will keep them together, force them together, that is the one that's called the strong force. At the same time, there are other subsystems of the universe that may not be repelling as much. They have minimal repulsion. They may have even some attraction, but they still need to be kept together. They could even be neutral bodies. They don't really attract, but they need to stay together. They don't attract or repel, but, they need to be staying together. The force that keeps those kinds of components together is called the weak force. So these are the 4 that have been identified up until this point by scientists and mathematicians and physics. So there has been a study through generations of humanity, and what Brother Booker is basically addressing here in terms of the connection with the Shabaka, giving its historical time kind of setting, is that it was always there in the Shabaka stone, but in relatively recent times, relatively short past, the people with the solution, of course, had been under siege and under all kinds of trying moments, and so have been put in a position that they were not really looked upon as the ordained source of that knowledge. Like Brother Booker had pointed out, the solution had been, buried already in the Shabaka stone. And it would then seem that there is some level of destiny then that the African, wherever he or she is, was supposed to come up and share that with the world. But because the African, ironically, was the least expected to do that due to one lack of information or another, they were not considered at all. As a matter of fact, physics and mathematics, especially mathematics, which our ancestors were used as a source to bring it to the world by the Almighty God, you will be surprised to know the level of African people getting degrees in those areas. And certainly in physics it's quite similar. Because as is very clear in history, geometry was what our ancestors did probably better than anyone that has lived on the surface of this earth. Not only did they do the theoretical developments, but they practicalize it in terms of the pyramid and stuff like the Shabaka stone and the use of lasers and sophisticated kind of incredible dimensions and extensions of mathematics or geometry beyond the level that most people are familiar with. It's as if it's actually a spiritual expression, which is why the English author, who wrote a book, The Fingerprints of the Gods, Hancock, called the book The Fingerprints of the Gods. In other words, that the awe which overwhelmed him in looking at the practicalization of geometry, and the other sciences by our ancestors, were so high, such a high level, that he couldn't simply believe that that could be done by human beings. That's a testimony to the kind of sophistication and God's blessing that had been bestowed on our ancestors. But ironically, in the present time, it's hard to see the evidence of that in terms of the number of graduation of people of African descent in mathematics or geometry or physics or even chemistry. The name chemistry, is actually the science of the Kemetic people. That's where the word came from. Chemistry, chemistry. And when you put math and chemistry together, you get physics. Okay, so there are quite a bit of evidence in terms of historical and even, goes beyond history in terms of the spiritual, sign that says, yes, these are the people that were actually ordained to bring such information, and the importance of a unified force. It's actually going back to the concept of the Almighty God, because that's the most awesome force. And when you're looking for a unified force, you are indeed looking for the Almighty God, the Creator. That's the author of force. That is the entity behind any motion that exists in the universe. And so unified force is the world. Unified force is the universe. Unified force is the embodiment of creation. And that's why it is so important. We can transform within a conservation, as we talked about, but that we are basically part of that unified force. Okay, we could go from one form to another, but we come from one original source, and that's basically what the search for unified field theory is about. But it takes some history. It takes the current realities in education and the university systems, where, for example, in my search, when I was starting out for mentors in terms of people of African descent, it was basically non-existent. So like I said before, this development is thoroughly unexpected to the world. No person would have ever guessed in their in any way that it would be somebody of African descent that was going to tell the story. And as I've shared with most people that I talk to, the reason that is the case is because the ancestors, have the keys to the truth. And so the rest of us who came later, one way or the other would continue that to tell that truth. And so, this is the context in which we're discussing the unified field theory. Because it's a central force within the creation itself, it has so many implications. And like I said, when you can link it to the force of creation itself, which is the Almighty God, then you can understand what I'm talking about. People, for example, want to go back to understand creation. Is it the Big Bang Theory? What happened when time, when the time began? Okay? And so you can see then how it is important not only to find the unified field theory, but to use that theory to go back in time to actually get a better sense of how the Creator actually created the universe. Okay? So it's not a trivial matter. It's not a trivial undertaking. It's not a frivolous one either in terms of its importance. So it is within that context that I began my search very young when I started, as I mentioned in the interviews before, basically in the high school. But before then, the elders who I studied under had already been giving me a lot of information in terms of, my position, as a people, as a member of a people, of a race, what my job was supposed to be. By looking back and seeing things, I guess I must say that I may have been quite fortunate, to have that kind of education and information, which of course made my search a lot more focused and more, inspiring and more energetic for me. So, of course, it began, formally or semi-formally at the high school level. Okay, but even in elementary school, I tried a few things, thought-wise in terms of thinking about, what to do with mathematics and so on. To go along that direction, I didn't formally know it at that time, but I knew, somehow that was where I was headed. So then in the high school, one of the early things that I remember in the high school was taking a formula, which I've shared with many people. If you were adding numbers from 1 to any number, you would, for example, 1 plus 2 is 3, 1 plus 2 plus 3 is 6, Suppose you continue doing that, let's say you want to add up to 100. Of course, if you have some time and paper and pencil, you can do it. I mean, you know how it can be done, okay? But if you don't have time, you just think about it and say, yeah, it can be done, but I don't have time to do it right now. So then what I wanted to know is how I could find a simple way that, to do that. And so that took me into sitting down and trying to find a formula, a mathematical formula, which in many ways is transformation. You transform that tedious problem into a form that's also geometry. That's the gift of the ancestors. You transform it into a space where it is easy to do. Okay? And so after struggling with it for a couple of days, I came up with a formula, which was if the number that you're stopping was n, as an arbitrary number, then the sum, adding the number from 0 or 1 to that number n, will be equal to n over 2 multiplied by n plus 1. Okay? And I did that, and then I plugged in n over 2 multiplied by n plus 1. So, of course, if you add 1 plus 2, you get 3. So 1 plus 2 means that you're stopping at 2. So 2 over 2 is 1. 2 plus 1 is 3. So 3 times 1 is 3. That's the answer right there. And you can plug in any number, even a million, okay, which certainly even a computer will take some little time to do that. But there is one that could take the computer an impossible time to do. Okay? But this formula can do it. Because all you need is, you find a number where you start. Suppose it's 10 to the power a million. Okay? 10 to the power a million. That's going to take a computer a lot of time to do that. But all you need is you have your 10 to the power a million, you divide it by 2, add 1 to it, and and then maybe I don't okay, the formula that I'm talking about is okay. Thank you. What I'm talking about is the sum. If you're adding 1 plus 2 plus 3 plus to n, okay, say that is equal to, okay, s of n. S of n is equal to n over 2 n plus 1. This is what I found in the high school. And like I said, if, let's say n was equal to 10 to power a million, okay, to 10 to power 6. You try giving that to a computer though, I mean, let the computer add that kind of number, that's going to be horrible. But technically, you will have that as S 10 to power 6 is equal to, you just substitute it here, 10 to power 6 over 2 into 10 to power 6 plus 1. That's an answer. The computer will have a difficult time trying to do that. So it will be crunching, you may run out of energy before it gets to do that. So that is the power of transformation, okay? There is a transformation. You transform this difficult problem into a space where it's very neat and simple. And that's the basis of the unified field theory. It turned out that this formula that I did in high school was the same formula when I took it to my teacher. I guess he was a Frenchman. He looked at it and he basically he gasped, and I think he almost had a heart attack when he saw that. He was the math teacher. And he said to me, "Do you know what you just did?" And I said, "No, I don't know. I thought I just found the formula." And he said, "Does the name Gauss mean anything to you?" This is Gauss. "Does the name Gauss mean anything to you?" I said, "No, I have no idea who he is." But he says Gauss is considered, along with Newton, okay, and Euler. Of course, he was a European, or he's a European. These are the greatest mathematicians of all time: Gauss, Newton, Euler. And that this guy came to fame by finding this formula. This was his thing his claim to fame, as they say. So how did you do it? He says to me. I said, I just sat down and I looked at that and I put that end down and tried to do some little serious thing, and that's what came up. So from then, of course, I will earn a nickname of Mr. Calculus. That was my nickname in high school. By the time, of course, I got to 10th grade, I became a teacher of calculus. Okay? So you would have thought that I was going to be teaching, 9th grade is where people start calculus, teach 9th grade. But I wasn't teaching 9th grade. I was not teaching 10th grade. I was teaching 12th grade. And actually it was what they call popular demand by the people in the 12th grade who were my seniors. And the boarding school that I went to, being a senior was a very significant thing. I had to wash their clothes, at least up until that point. I do the laundry for them. I mean, because they were 2 years ahead of me. In fact, even 11th graders, that's the tradition in the high school. So, but when it came to being a teacher, they had no problem, saying, yeah, let that young man come and teach us calculus. So they would take me there, and but I was rather small, so there was a little chair that I had to stand on to give my lessons. But it was fun, they had fun just as I had fun. So, but this name stood with me throughout. As a matter of fact, there are some of my classmates that still address me with that name. One wrote me a letter a couple of years ago, and still remember that after 30-something years. So the kinds of circumstances that surround the search. But part and parcel of this kind of development in terms of mathematics is the philosophy from the elders, the African philosophy, which was luckily quite alive and well in the environment that I grew up. Okay, you were taught your history. You were taught who you were. You were taught about the war you lost 500 years ago. Okay, and how you became a POW, a set of POW, in 3 categories. One that were left on the continent, one that were dumped in the Atlantic Ocean, and one that came to the New World and other places. And so in other words, you were geometrically and spiritually in a plane where you had information. You were quite and then the other thing they would have us do is to trace our ancestry. Okay, back as far as you can. Okay, I can easily trace mine to 1100, and by projection back to the pyramid. Yes, Egypt. Okay, and so every young person, to show that you grew up well, that you are a true black person, you're an African, and that knows him or herself, you have to embark on doing stuff like that. So you're not just black and proud, per se. You're black and proud because of the glory of the Almighty God that blessed you with so much. Okay, so much food, so much knowledge, so much mathematics, so much civilization, cradle of civilization, so much history, so much love for humanity and all that. So you got to go through this, and what that does is really keep you continuously in a state of positive experience. And that, nourishes your development. It energizes you in terms of your growth, academically, spiritual, and so on. So all that added to the search for the unified field theory. So with things like this, I would move on to the university. And one of the pieces that was done in the undergraduate was a study of the rocket. I did in a book called, it's a published book. Okay, the gas turbine testing, okay, by myself. I basically studied the principles of rocketry and how math plays a role in that, okay? And I remember a professor by the name of Professor Peter Wojcik, okay, a very brilliant Polish professor, described this piece as a masterpiece. Those were his word. That was his word in describing the gas turbine testing. So again, there was an application of mathematics, the philosophy, the African philosophy, and and the appreciation of what the giver of knowledge, who is the Almighty God, has done. So then we moved on from there. At this point, of course, one of the things that I was quite interested in doing was making sure that the gifts that seem to be apparent in my system with mathematics was not just trivialized by people who look at mathematics as some form of abstract thing, that has no use except for some trivial self-gratifying kind of feeling, that you're supposed to get from abstract mathematics. Okay, so for example, getting that formula to me had a lot of practical implications. It isn't just some abstract thing. It has, like I showed, the comparison between that formula and the computer. There is certainly an advantage. So then I wanted to make sure that people did not misunderstand my role as a person that studies mathematics. I hated being written off as somebody abstract that has no impact on the humanity or practical situations. So I made sure that whenever I develop the mathematics, I would look for an application. This was the first practical part, in terms of, the university years. Okay? Because what happened was, the man helped me see rocketry, because this basic book here deals with rocketry, gave me an insight into rocket science. And to, again, get back to my base as an African in terms of where such an idea could have come from. Later on, I would come across the name of Andrew J. Beard, an African born in this country who had no formal education, invented the rotary engine. Okay. Rotary engine, which is basically the principle of the rocket. And the interesting part about Brother Beard was the fact that they said that he didn't have any formal education. So then you ask yourself, how does a person walk off the street or walk up his mother's womb and create a revolution of this type? Of course, he is an African. That was the good beginning. Then come to find out, there is a toy, in other words, trying to explain this revolution, there is a toy called Chico, which is an advanced toy for an African child. Okay? And Chico is something of this okay, something like that, and it's got another component like that. Okay, this is cylindrical, and this is also a little cylindrical, and it's got a piston type thing here. And what happens is you can insert a bullet-like thing over here at the, it's hollow, it's like a bamboo or something like that they build it from. So you have this piston here, and the handle, and there's some brush at the end of the piston. Okay, so you could move it in and move it out. The brush serves as a valve. There's a valve there that when you're going in, there is a compression of air if you allow air in to begin with. And then when you come out, of course, it expands and so on. So this is a toy that an African child uses. And what happens is, with this bullet in there, you can compress enough air in here to project, and send this out as a projectile, okay, or like a bullet, okay. So I looked at that and I said, my goodness, then probably it's a relationship with that, the cheekbone and the rotary engine, that occurring in Africa, and this man being an African. If he didn't have a formal education, the only education he had was what his father and great-grandfather taught him, which is the African education. And so there was a theory that says that is linked to cheekbone. So again, rotary engine connecting with gas turbine and then with cheekbone. Of course, for most people who understands the good part of the other history of the African in terms of the pyramids and so on and so forth, that is not far-fetched. That's a neat kind of thing. So this was the kind of thing that one picks up as you move on in the search for unified field theory. Every time you get something of this kind, there is a reinforcement in your efforts in terms of your determination to get the job done. So we moved on from there. By the end of this project, after having demonstrated, especially with this guy here, fine professor, Professor Wojcik, calling this work a masterpiece, that was well appreciated, and then energized me further. So then got into a field called, a field of transformation called Affine transformations. While actually in high school, what I would do is, in terms of my search for the unified field theory, first I wanted to understand the relativity theory. And I remember every time I would go to the library, I would go to that section, of physics and mathematics, where, there would be books on physics and relativity. And each time I would pick that up, the other kids would laugh at me. Even other grown-ups would laugh at me and say, what a crazy guy, look at the kind of crummy book he's looking at. And Michelson and Morley experiment in terms of ether and all that, I will read that over and over. The Lorentz geometry, quite vivid. I remember the books, Dover type books, that were and I would read that over and I would, and I'd say, gee, wouldn't it be nice if one can go beyond where they are? I'll read and just get information and move on. So eventually, the field of transformation called the Affine transformation. I began to get into that. Of course, that's the same transformation that Lorentz used in explaining the special relativity. That developed, and in the process, of course, I met with a professor, in my graduate years, actually, my graduate years, I met with a professor, a very renowned professor, called Eugene Brunel, E.J. Brunel. Eugene Brunel got all kinds of awards in MIT, became one of the youngest professors to ever be appointed at Princeton University. Like one of his students became the chairman of Grumman Aerospace. Renzo Caporelli was his PhD student at Princeton University. So I met him, and he was quite advanced in affine transformation studies. Had developed some really neat stuff. And so I began to work with him, along with some very notable other mathematicians like George Handelman, Bob Lowy, and Henry Nagamatsu. These are some of the finest scientists and mathematicians that I was blessed to work with. So in the process, we wrote some, PhD thesis that did a lot of analysis of affine transformations, from geometric, spiritual, aeronautical, all kinds of dimensions. And that work received a lot of, how can I say it, praise from the mathematics and engineering communities, because it has application to aeronautics. So that again energized me quite a bit. And so the fact that it had been used in relativity was always there behind, in my mind. Something that was used in relativity that is quite abstract could indeed have applications in aeronautics, designing airplanes to be safe. So I said, gee, there must be more to affine transformation, because what affine transformation did in relativity was to really explain the concept of special relativity, which in a specific form, which is the wave equation, is a well-known equation in mathematics. But in terms of explaining physics, the special relativity calls for a transformation of that wave equation into a certain mathematical space. And this affine set of transformation, that the special one that Lorentz chose, could transform that equation in such a neat way that the character, the properties of the waves were preserved. Okay, there was no changes at all, and that was also one very significant. In the process, of course, he explained what special relativity was talking about, to the joy of Albert Einstein. And of course, that energized Professor Einstein to go further, into this general relativity, and beyond. And so I took note of that, but my first application, of course, was the aeronautical application in aeronautics, where obviously there's some significant problems. Most people may not realize the connection, tight one, for that matter, that exists between what you call physics and aeronautics. Aeronautics is the physics of gases and bodies that fly, through air, and so on. And so it's very much like studying physics. For one thing, air is basically composed of particles, molecules of nitrogen, oxygen mixture. And so, when you're looking at a flow, it's like looking at particle physics. And especially when it gets into the rarefied mode, then of course you're really looking at the particles. So the equations, the same equations are used. to describe those kind of aeronautical systems. So it was not totally unconnected what was happening there. It was studying physics. So, so that development received a lot of attention. In fact, in terms of research citation, the last time I counted, we had, I noticed that I had over 100 citations, you know, in terms of other researchers using, you know, works like those affine transformation works and the current work and so on and so forth. And 100 citations is not a bad number at all. So then you got a sense that, you know, you had more work to do. Of course, at the basis of all of that was the unified field theory. You got to find that. Okay? Einstein took the special relativity to a new ground in the general relativity theory, in which he concentrated on gravity. That concentration of gravity came as a special choice. What he wanted to do right away was, of course, to unite all the forces and look at force fields on his way to actually finding a unified force. When that was not immediately available to him, he made a choice to just concentrate on the gravity. And he did a marvelous job with that, developing the general relativity theory. And basically, general relativity theory concentrates, as I said before, on gravity. What he did was basically extend the affine transformations that were provided by Lorentz to explain the special relativity theory into an arbitrary space. In that arbitrary space, in other words, affine transformation, you know, if you have one space here, okay, say in the two dimension, y, x, okay? And you want to go to another space, okay? Y prime, x prime, okay? You could use all kinds of mathematics. For example, you could say that y prime is a function of y, x, okay? That is a transformation. And that x prime is equal to x prime, a function of y, x. Okay? Depending on how you define that function, which could be maybe ax plus by, okay? That may be your transformation. And that's the kind of class of transformation that's called affine transformations if A and B are constants. Okay? It could be much, you know, you could add C here and so on. But if you have that, okay, and similarly, you know, you could have C or D, X plus E, Y, you know, plus maybe F. Okay? If you have that, this will be considered an affine transformation. Okay? Of course, there are certain conditions and so on and so forth that will verify, you know, certain properties. But generally, that's the kind of thing you're looking at. So you could develop from here another space, okay, that will be different from this, but that will be a function of this. So what happens is we have equations here, okay? That equation can be mapped into an equation here, okay? Call that equation, you know, and that could be a physical equation. okay, then this you may consider to be a math space. So, these types were provided by Lorentz. Okay? Now, having seen, and this, in the mathematical terms, these are rather simple transformations, except they also, they explain special relativity, this simple stuff here. So then Einstein then said to himself, my goodness, if these simple kinds of transformations can do so much, what if I make them more sophisticated? Okay? If I make them more sophisticated, what can I get out of them? And that's when he just then, began to just look at this general situation here. The so-called general coordinate transformations, where this is arbitrary. You don't know it ahead of time. This is specified by putting the nature here. You could have x to the power 2, 3, and so on over here, but you just chose one, okay? Power 1, and so on, and constants, okay? You can transform this here, you go into that math space with this equation, you have a simple problem. You can see better, which is the power of transformation. If a problem is difficult, it's because this space where you have it right now is crummy. You cannot see, it puts you at a disadvantage. In other words, you're looking at it from a wrong point of view. So you want to get it into a space here where it is nice and clear for you to see. Okay? You can just look at it and the solution will jump at you because you're looking at it loud and clear. Okay? So most physical problems in this space are difficult. And so what he did was to take this general transformation, coordinate transformations between this space and that space. Of course, general is good, okay? However, there are limitations. You can't be that arbitrary, because when you really want to solve a physics problem, you got to narrow it down, okay? Not only that, the constraints in terms of the difficulty of the equations will force you to narrow down. So what he did was, he put down certain rules, in other words, even though they are arbitrary transformations, he wants to ensure, for instance, that there is something called a covariance. Okay? Variance. Okay? A covariance between systems here and systems here. In other words, if you are looking at acceleration here, you will look at something that looks like acceleration or equivalent in mathematical form to acceleration here. That's the principle of covariance. So he enforces that. Okay? So, which in effect means that he is actually transforming the equations, the physical equations from this space into that space. He wants to maintain the integrity, the form, rather, more seriously, the form of the systems here, the parameters here, the forces here, and that mathematical space over there. So in the process, he was able to, for example, force in this space could be written as d squared y, okay, dt squared, okay? That's acceleration. Okay, you multiply that by the mass, you get force, okay? Or that if you take that down here, F over m, if mass is for the time being considered the constant or not very varied, then you have force over mass, which is acceleration. Okay? Acceleration, therefore, is a derivative of space over time, you know, 2 times, okay? So then what he found, what he did was, in the process of this general transformation, he was able to get something like d squared tau d eta squared, okay? Where tau and zeta were general functions of this here, and I don't want to get too complicated here. But what the interesting relationship is that, first of all, this now, okay, if you put time in here, okay, say if you put time and z here, okay, you can imagine that time, z, this becomes, you're now in the world called the Minkowski's world. Minkowski. Okay, Minkowski's world. Okay? Which basically is space and time. X, Y, Z, and T. Okay? So, in that space, now this is no longer time. Actually, you could call this zeta. It's probably better that way. And then this is tau here, so that you could see a relationship between tau and t. Tau is still a function of x, y, and z, and t. Okay, but this is just time. But the nature is the same. D squared zeta, d squared y. So there is a covariance between these 2 terms. So he's got this in that mathematical space, and this is what exists in the physical space. So he enforces this rule here that these 2 must have the same form, which is the principle of covariance. So then, as far as this world is concerned, therefore, he is basically looking at a force per unit mass, because that's what it is in the physical space. So this looks like a force per unit mass in terms of interpretation, even though it's not exactly that, but that's the form. It's got that form. So this was his major contribution. From here, then, he will find out that the zeta are called geodesics. Okay? Okay, zeta, okay, as a function, I'm sorry, okay, x, y, z, t are called geodesics. G-O-6. Okay? Which are the curves, the shortest curves between 2 points, okay, and basically the trajectories in which a gravitating matter would go on. You know, you have a rocket goes through a trajectory, okay, because you have a propulsion force that pushes in that trajectory. If you are under a gravitational propulsion forces, you will go on trajectories called geodesics. That was from that mathematical transformation, he was able to identify this as the trajectory that a gravitating matter would go on under the influence of gravity. That was his major contribution. There was a lot of physics in that development. It tells basically a good part, if not all, about the story of the gravitational field. In the process, he was able to develop results which would confirm Newton's gravitational force. Okay, Newton's gravitation. Okay. And then, in addition, he will find another component which Newton did not find. Newton's development was another inspirational kind of occurrence. He came up with a formula that the gravity force field, he just gave the formula. Says this is what happens, this is what the field looks like. And it made a lot of sense. Nobody knew how he obtained that equation. Okay? But it was spread. So it wasn't until Poisson, French mathematician, came over that he devised an equation which would actually explain where Newton got that thing from. Newton himself did not have this equation. So, but when Einstein, developed the general relativity by identifying these geodesics, the trajectories on which a gravitating matter like yourself or myself will follow if we are under the influence of gravity. That also means the planets, the solar systems and everything else. Okay? He was able to confirm that Newton's result and then find yet another component, all for a gravitational force field. And that component was the wave component. Okay? What Newton find is what they call the classical field. Okay? Einstein confirmed that classical field, okay, and then also find a new one called the wave component. Okay? The wave component was, found by Einstein, the first person to find that for gravity. All this is gravity. So, of course, it was controversial at the time because people didn't think that the gravity field had a wave component. Okay? Well, even up till today, there's some controversy and so on. However, data show that that's real, that it does exist. So a lot of credit to Professor Einstein in that respect. So, now, as the gravitational field discovery and work was going on, of course, Maxwell, an English mathematical physicist called Maxwell, was doing work on electromagnetic fields. Electromagnetic field. Okay? And he had developed a set of field equations for electromagnetic field. Okay? And in looking at the effect of an electromagnetic field, it was clear to Einstein that there should be some kind of common origin between the electromagnetic field and the gravity field. Except he didn't know how to get that common origin. So he had to search for it. In fact, the general relativity theory, which is based on this kind of transformation, general relativity, okay, which is basically based on that, was modeled after Maxwell's equations. Because once he wrote that, the covariant formula that I told there before, which was basically called the ponderomotive equation. That was the starting point. In other words, the impact or the effect of a field would be to cause motion. And that was, when you have acceleration, you have motion. So that, that says, okay, that particular acceleration will have to be as a result of the gravity field. Maxwell had a similar set of equations. So in order to complete the set with Newton, he had some other equations as well, which, as our work progressed, we would identify as the other components of the unified field equations. So here you have gravity, electromagnetic field. And now Einstein wants very badly to combine them. He developed his through a mathematical transformation. This was slightly different form. A good part of this development were done in a physical space. His was in a mathematical space, which he identifies as the geodesics. So what he wanted to do was to transform this as well into that mathematical space and have them in a common space. So that his geodesics now would be a trajectory that a matter would go on when they are under the influence of gravity and or electromagnetic field. What he did here, as we would explain later on, by the grace of Almighty God, was basically to start from what we call the mother of equations, i.e. the unified field equations, what we call also the generic universal conservation equations. Conservation, as I've described it, is very much a sound principle in just about every field you can think of. If you have some money in your pocket and you spend some, you throw some away, you give some as handout, at the end of the day, when you add all of them together, it's the same amount you started. You haven't made any disappear by way of abracadabra. And that's basically what you were saying as well. That the fact that you didn't see the money did not mean that it doesn't exist. It's in somebody else's head. Okay, it's the person that you bought stuff from. So it didn't disappear. It just went, transformed from one hand to the other. So in effect, that's the whole principle of conservation. You do conservation within the context of transformation. That money is transforming. But if you put a global net around where it is transforming to, that's conservation. So the generic universal conservation equations, therefore, are the unified field equations. Because everything is buried in there. Every force that you can imagine is in that general conservation right from the beginning of time. And then that's a summary of what the Creator, the mightiest of all, forces is. Because everything else is in and is contained in there. We are all part of that conservation unit, that is conserved. It's extended, transformed here and there, but you're part of that whole body. And I think the Bible and the good books address that on some level. So when you have that whole embodiment, then it is conserved. It is conserved in space and time, in the so-called Minkowski space. It's conserved along that line. That was a principle that we were shown by the greatest force. And that when Professor Einstein did that transformation and identified that geodesics as the trajectory on which a gravitative matter will go under the influence of gravity, he basically has isolated from that totality one kind of force, which is the gravity. And by using his experience of how gravitating matter are supposed to behave, he was able to identify that. But that's just one out of so many. People would like to think that there were only 4 forces. That may be what we know right now, but that by no means. There's no mathematical proof that those 4 forces are all that there is. But when you are working within the mother equations that conserve the overall entity, then you know that everything is in there. Those were the equations that we used. We can see how on a special assumption the electromagnetic field force will come out. Under a special assumption, we could see how the general relativity equations or Newton's equations, Schrodinger's equations, or any other form of field equations that have been developed by anyone that we know would come out of the mother equations, which is the way it's supposed to be. We came from the father, or the mother, or whatever they call the mother equations, which describe the entity. Then that's where we came from. So you can take one individual and so on and so forth and look at them separately. Okay? Yes. You look at them separately, you would have a good view of that particular entity. But if you want to look at a combined picture, you can also get that too. So first thing then was to identify one by one all the components of the equations of general relativity. General relativity equations are considered field equations, gravity field equations, just like the Maxwell's equations are called the electromagnetic field equations. Component by component, like the ponderomotive motive equation, that came from the conservation of momentum in the mother equation. When it says conservation of momentum, it didn't say that you're looking at one force. Momentum can be caused, and it's generalized momentum, which could be caused by any kind of force. Okay? So he took that from there. It's very clear, acceleration is acceleration. It looks exactly like it. And he further said that there is a covariance, which means that if where he started with acceleration, what he has there is a form of acceleration in the other mathematical space. So one by one we were able to identify where they came from within the mother set of equations. Then we went to Maxwell. Whereby I had some of my kids, check the Maxwell equations out. I asked them to get a book by an English professor from Cambridge, a math book. They went and got the book, and I said, look for the electromagnetic field equations. And they searched for it, and I said, write them out. And they did. And lo and behold, they're right there in the model equations. And so 2 down, 2 more to go. Now, remember now that we've allowed for every kind of possible forces there. We simply can identify the forms of the ones that they've identified. So we looked at the strong force and the weak force, and we could, write a proposal in terms of what their nature should be, based on what we've seen with these others. And the more we look, the more amazing. Okay? The more we look at the work, the more amazing the results look. For example, whereas in the electromagnetic field, the wave nature had been identified. Okay? Wave nature of the electromagnetic field had been identified by Maxwell's and a lot of others. Okay? Now, Einstein was the first to identify the wave nature of the gravitational field. We were blessed with solutions to these mother equations, which are the unified field equations, from where we could recover the solutions given by general relativity, the general form of it, the solutions given by Maxwell's equations. We can identify both the classical component and the wave component, and indeed a third component that we have not seen anybody present, which seems like a kind of component that would come as a result of a skew nature of the Minkowski space. It is not symmetric. It's symmetric in space, but not symmetric in time. So there is a component as a result of that lack of symmetry in time. That, showed up in our work as well, in addition to these two that they have. And that goes across the board, whether we're talking about electromagnetic, the general relativity, which confirms Einstein's finding. But even in the strong force and the weak force and the unknown force, which has not been identified yet, these components were quite present. That's one part. Another part was the mother equations, which is the generic universal conservation equation, which embodies everything in the universe. You want to talk about theory of everything? That is where you'll find theory of everything. As long as you look at them as generalized mass, generalized momentum, and generalized energy. In the so-called Cartesian coordinate, that amounts to 5 equations. Okay? Mass and energy are scalar, so there will be 1 equation each. The momentum, there are 3 of them, x, y, z, so there are 5. Einstein, in the special relativity, was able to collapse energy and mass. So he reduced the number of equations to 4. That was one of his major contributions. What the principle of conformal invariance of these mother equations identified to us, that all the equations that comprise the mother equation, which is the unified field equation, actually amount to one, which is indeed the unified field equation. The mass, so not only are the mass and energy equivalent, which will bring you 4 equations, but the mass and the momentum are also equivalent. Equivalent to energy as well, which says indeed you only have 1 equation. So what has been done over the centuries without the benefit of the Shabaka story is to write superfluous equations and count them. Einstein first identified that mass and energy are superfluous. And the Almighty God now shows us that the others are superfluous, so you have 1 equation. And this part was reviewed at least 2 times by the American Mathematical Society and recognized. And once, at least once, by the European Mathematical Society independently and recognized it. And of course by the Russians and some of the toughest reviewers in mathematics have reviewed it and signed off on it. Of course, for the American Mathematical Society, one of the reviews was done by Guillaume Corot. That's a Frenchman. Professor Corot, who is a leading expert in this particular field. He reviewed and blessed this development. Of course, there's Kankin, who did the extension too. As a Russian, a very, very no-nonsense Russian reviewer. And then Chichaka, who I think she was the representative from European Mathematical Society that reviewed the hydrodynamic part, which is Navier-Stokes. So, in summary, that is the unified field. There are a lot of other details in terms of the basic mathematics, the transformation groups, the new group theory that developed, that help us find this. So it's something that obviously I can continue for as many hours as need to be discussed, and I don't know how much time you have, but those are the essentials. The essential thing is identifying the mother equations, which are the generic universal conservation equations, identifying them as the unified field equation, or the theory of everything, or the unilaw. The uni part, or the 1 equation part, is the fact that there may be 5. Einstein showed there are actually 4. This development shows there's 1. And if there's only 1 equation that people are looking for that describes everything, and we took the equation for everything and transformed it into 1, then it seems to me that those 1 equations are same and 1. And that's basically the summary.
And now, a word from our sponsor.
That's the infinite knowledge that I can access, but I've kind of capped my well. So I really love it. So seeing it presented now has opened up my well a bit more. I really appreciate it.
Abit's secret.
What was the target audience? This book is for everybody. If it's early years, you read the stories in it and you show them the pictures. And you might think some of these pictures are advanced, but in your early years, everything is advanced, everything is detailed. You're seeing detail in everything. So it's good for them to see those things at the early age, hear it in a natural story, and later on, as they get older, you unpack it. So it's from early years, even I'm a great fan of the pre-birth stage. So if you could have a one that is pre-birth, you read the story. Because it's about space, they're coming into a greater awareness of their space. So it's every age, every age. For a parent, it's a great insight for a natural, nature-centered way of learning. For a teacher, it's a great resource.
Abit's Secret. Out now.
You need to be fully nourished. This book is one of the things we need to consume.
What I've seen in this book is that this book is revelatory also. So it's not just revolutionary, it's revelatory in terms of each piece of understanding builds a deeper understanding that actually comes from within.
Get your copy at abitsecret.co.uk.
And so it really provides a very deep and very clear step-by-step way for one to learn how to resurrect community.
Yeah, resurrect is it's a bold statement, but it's a true one. It's a resurrection.
It will be beneficial to the children, depending whether they're small, teenager or elder. Even us adults can learn from this book as well. So,
for more info or orders by phone, call 020 8144 1720.
The book was just amazing. It was a great read through. I just think it's a fantastic book. Bought 2 copies, one for me, one for my grandson. So I just know that it's going to be great. There's a wonderful website as well, and then there will be more books in the series, which I can't wait for.
ABITS secret.co.uk. abitsecret.co.uk. For more info or orders by phone, 020 8144 1720. Abit's Secret. Out now.